Hi everyone, thank you so much for coming for Python for data science. So last week we started talking about pandas and series, how to create pandas, series, how to populate them, how to read from them, how to read the rows and columns. We have learned all of that. Today we'll move on to bit, and as we move on, I mean, you know the idea why we're going to use the data of the pandas and NumPy and for it's for eventually for data science analysis, then for machine learning, and then for deep learning, artificial intelligence. All right. So when you come to the deep learning, machine learning, when you have a very strong experience with pandas where you could manipulate the tables, let's call them the table, the data frames. One of the things that you need to do always to join multiple data frames. So sometimes you'll have data frames, data sets that have the same title, but they have different different features or different attributes. We'd like to join them together. How? What you're gonna do with missing data, what you will do with repeated data, how can you do normalization. Okay, so working with data frames is that before you start applying your techniques in machine learning or data learning or doing the analysis, okay, you have to do a lot of formatting for your data frames to make them ready. And these techniques, these tools, you have to learn them. You have to be fluent with them. All right. If you don't know the tools, okay. And by the way, the tools is pick and choose. Depends on the situation you have. All right. So it's a very important that you have to be very strong in such things. Okay. So we'll try to give you head-ups, like titles, like examples of what you can do. But you know the manual for Panda, I think it's like 2,000 pages. All right, I downloaded it, so all right, so it's you know a lot of things you could do. All right, so let's talk about data. You know, data assembly. Okay, handling. You know, the data. The most important thing that you need to do with the data is to make it a TD data. You have to work with the data frame to create something, what they call it, a TD data, which was an idea by this person, Welcome, published in a paper. I gave you the link of the paper, it's like about 20-30 pages. Take a look at it, okay? Just the idea of having a TD data. All right, the TD data is a framework to structure data sets so they can be easily analyzed. You could write any table, any data frame. You could put the rows and the columns and the column titles the way you want when you collect the data. All right? But when you start writing the code to analyzing the data, sometimes you need to change the format, the look, the columns, the rows of your data frame. How you do that without losing data. Why are we going to do that? To create TD data, TD data. It's a very nice article. I truly recommend you to take a look at it if you have time. When TD data is considered, these are the aspects that has to be taken care of. Number one, each row is an observation. Remember that what we said, you know, when you look at the data set, any data set is built of, okay, rows and columns. So row 1, 2, 1 million, okay, what we call this? Observation. Okay, and then we have in here name, whatever, height, weight, whatever in here, what we call these features, right? Or attributes, okay? Or column names, okay? Depends what you are talking about. So each row is an observation, all right? If you are, for example, this table talks about like 2,000 diabetes patients. All right, so there's 2,000 different people in here. Okay, so we cannot have the same person twice, one person, right? And these are features of the person: his height, his weight, his age, when did he start having the disease, what kind of medicine he have, what is the average number of his glucose or glucose in the morning, so on and so forth. So observation in here. All right, so if I have like one repeated rows from one person, I have to normalize it. I cannot have that. Number two, each column is a variable. So each column is a variable, not a value. So if we have a values, if we have a column as a value, we have to convert it to a variable. And we'll talk about that in a second. Number three, each type of the observational unit forms a table. So this is the table, okay? You could have multiple tables that you need to do. So that's what we're gonna talk about today. How can we have TD data? Okay, how we manipulate our tables in a certain way. All right. So combining data sets. I'm not sure why my title is gone. Okay, but you know, everything is not working right in this room. I think there is a gap in here, something wrong with the projector. Anyways, combining data sets. So when data is TD, you need to combine various tables together to answer a question. So the table, I mean, you know, usually when you need to have a process to answer a question, it could be, for example, what is the average weight for those people having, you know, diabetes? In our example in here, for example, right? Question. So you need to handle that. For example, there may be a separate table holding company information, one table, and another table holding stock prices. If you want to look at all the stock prices within tech industry, only tech industry, not medical industry, not the pharmaceutical industry, not structural industry, tech industry, we may first have to find all the tech companies from the company information table, and then combine that data with the stock price data to get the data we need for our question. So you could have multiple tables, like in database, multiple data frames in our case, that we have to combine them together to answer a question that we need to look for. So we have to understand the structure of each data frame we have. The data may have been split up into separate tables to reduce the amount of redundant information. If the table, it has a lot of repeated information, you must do that. You must do what we call normalization. You normalize your data. And there is techniques for that. We'll take a look at some examples here. So you have to have a DD data. The data has to be not repeated in the table. If you have to divide the table, table of frame, and in this class today, when I say table, what I mean data frame. So we're not talking about databases, okay, but we're talking about data frames in here. So if you have a data frame that has a lot of repeated information, you have to neat it up. And if it takes that you're dividing your data frame in multiple data frames, that's fine. All right? We don't need to have a data. Remember that when we are talking about data sets, we don't talk about data set that has 10 rows or 100 rows or 1,000 rows. In real life applications, when you do artificial intelligence, you're talking about, data frame that can 4 million rows, millions of rows, millions. Big data. So when you have repeated data that you don't need, that is a disaster in your data, right? All right. Please feel free to stop me at any time. I know what to do. The titles are gone. Okay, I'm not sure what to do. Okay. So, so the first thing we do, the concatenation, to concatenate table. Concatenation can be thought of as appending a row or a column to your data. You have a table, you need to add more rows or add more columns to it, right? So this approach is possible if your data was split into parts, if you performed a calculation that you want to append to the existing data. Okay, so the concatenation, there is a function for it called concat to do that. Simple. Everything in Python is simple. Looks easy, right? There is a function, just you have to know to use it. The only problem, any function has so many options with it that makes it complex, but it's useful. All right? And always think of that as a utility for you, as a facility for you. If you don't have it, you'll write that much code to do it. But if you know that function or that option in that function, it will make it for you easier. You agree? It will make it for you much more easier. So we could have adding rows, adding columns with the concat, and we could concatenation with different indices. Maybe we have examples. Let's take example here. So we learned from last time that we're dealing with pandas, and we give it like a name, PD, short name, PD. All right. So let's say that we have 3 data frames. So we learned last time how we load a CSV. So there is, from Panda, there is a function called read CSV. All right, and we give it the path for the file. It will load it as a data frame where? In a data frame. So here we loaded 3 data frames, data frame 1, data frame 2, data frame 3. So how many data frames I have in my memory? 3. So I loaded them from the files. I put them where? In the memory in data frames. If I need to print the first one, so what do I have in here? How many rows? 4 rows.
Yeah, 4.
How many columns? 4, right? And there is a data in here. It's kind of 4 by 4, right? Okay, and usually the indices, just to refresh your memory, you always start from 0. Is the index column considered a column? No, it's just an index, right? And we learned last time the index could be like serial numbers like this, and it could be a string. It could be something, you know. You could do with that, right? So I have it here the data frame 2. Okay, A B C D, and different data. So we'll see in here they have the same table titles, column titles, and they have the same indices. So you know the trick in here, what you are trying to do for this example. Try to concat, to connect them together. All right? So very simple, if I need to connect them together, I have to call the function concat, and I pass a list of data frames. I don't pass a data frame, a list. It has to be a list, right, of data frames. It could be 2, it could be 3, it could be 100, all right? And by default, it will concatenate them by rows, which is axis 0. Remember what we said, will be axis 0, and this axis equals 1, right? All right? So by default, if I don't specify the so I created a new data frame, I called it row concat. Print row concat. What do I have in here? The concat. So what you notice in here did not change anything. 0, 1, 2, okay, put the indices as they are. I could reset the frame, and when I reset the frame, I could have the indices or the index reset. All right, very simple. All right, in here I have like 4 by 12 now, but you know, if you are having like 4 files or 3 files that each one of them have million record, this process is going to take a while till you see that, right? It will take a while until it happens, right? Questions? Then when you come in here, create a new row of data. So, what is the row in any table? Series, right? Yeah. So in here, what I did in here, a new row series, PD series, and I used N1, N2, N3, and 4. So it's a series I'm creating in here. If I print it, it's a series. So the type, if I do type for this, it will give me a series. So if we attempt to add the new raw to the data frame, okay, so we say concat to where? To data frame 1 and add this series. Okay, add this series. I did not give it a title. So it will add it where? Here.
Wow.
Okay, it will add it here, right? And for this area and this area, it will give it no data. No data. Okay, no data. Right? Feel right?
Can you explain again, sorry, why does it add to the 0, 1, 2, 3 for the previous one?
In here, when we're trying to add in here, you need the series in here, what's adding a column. When I use concat, okay, and I add a series, so, you know, it will add it as a column.
What
So
is the
series for column?
column?
Yes.
Okay.
Remember, series is a column.
Yeah.
When we create a series, it's a column, right? Not a row.
Okay.
Did I say row beginning?
Yeah. Yeah.
Okay, it's a column, right? All right, so it has to add to a column. We're going to add it. It's not going to add it with this, in here or here and here. Okay, it will add a new column. Okay, if it puts it in here, it will become part of this row. Nobody told it to be part of this row. It will create a new column and fills these with non-empty, right? So concat is a general function that can concatenate multiple things. If you just need to append a single object to an existing data frame, use append. Use append. Okay, append function. So in here you have data frame 1, right? We saw that before. Data frame 2. Okay, if I need to append, okay, data frame 2 to data frame 1, all I have data frame 1 dot, just like a method. Append to it data frame 2, and it was appended. Okay, it was appended there. All right. So we'll learn about concat, and we'll learn about okay. So append, how many data frames you could join?
1.
2.
Append.
Append 2.
Oh, yeah.
Right? I cannot join
So
one,
concat.
2, right?
Yeah.
But if I need to join many, what should I use?
Concat.
Concat. All right. Using a single row frame. So in here, adding rows. All right. So I have in here whatever a row, a data frame 1. This is data frame 1, and this is a row. All right. This is a row. If I need to append it, very very simple. Data frame 1, append, and the row, new row, df. So new row df will be substituted with the values of the row and will be appended in here. Right? So if you need to add one object with a data frame or a row, use append. Okay. In here, for example, if you could use, in here, using single row data frame. So single row data frame. All right. So again, if I need to add a row, I'll create a data frame with one row, and I'll add it. Simple, right? Or I could use, if I need to add multiple rows, I could use a dictionary. So in here, what I'm creating a dictionary. A equals N1, B, N2, C equals N3, D equals N4. What is this? What is this? Dictionary. All right. So data frame 1, append a dictionary and ignore index 2. So ignore the index. So ignore the index, right? So what happened in here? Okay, N1, N2, N4, N3, N4 was added as a whole here. if you need to ignore the index, remember that when we added there the indices were not in order. Okay, very simple. I use concat. So in here, how many data frames I'm joining? 1, 2, 3. And what did they say? Ignore the index. So that's why it was 1, 2, 3, 4 now 12. Before, if you remember, before, let me go here maybe. Here. We did not ignore the index, so it, okay. So in here, when you ignore the available index, just start fresh. Okay, it will put them for you with a new index. Good so far? We could try this in my computer, but I will not be able to finish anything. All right, I mean, just to write one code, all the codes available for you, all the data sets, I just post them for you also. Okay, and so you could download the zip file, expand it, okay, and try the programs at your own leisure. You'll enjoy it. All right. So now we need to talk about adding columns. So far, we learned about concatenating data frames as a whole. What we use, concat or append. We learned how to add a row. How we do that? By creating a data frame of one row and concate it, or by creating what? A dictionary and concate it, right? Now we're going to talk about adding columns. Adding columns. So it's a very similar for concatenating rows. The main difference is the axis is different. So before, by default, for rows, we use axis 0. Even we did not write it because it's the default. If we need to concat by the column, we have to specify the axis is 1. That's the only change. Everything else will be the same. So in here, column concatenation, concat, 3 data frames, and I specify axis 1. That means they're going to be concatenated by the columns. So what we'll see, A, B, C, D, A, B, C, D, A, B, C, D, and this coming from data frame 1, from data frame 2, from data frame 3, and we have it concatenated by. Remember, that would be problem if the size of the data frame is not the same, right? So you have to, it could give you a problem. And here, so far, is easy problems. Okay. In here, for example, what we are doing in here, column concat A. Okay, that's the column concat. That's the data frame we created. I don't want to print it all. I need to print only the columns that have A. So how many columns they have? 3 columns. So print the column concat data frame with columns titled with A. Printed the 3 for you. All right. All right. So in here, okay, column concat again, and they have a new column list. A new column list. So I have N1, N2, N3. So a list. There's a list in here. Okay, a list. So in here, so column concat, a new column list. What does it do? Forget about what does it do. What does it do? It will create a new column and give it a title of a new column list. A new column list, right? Right? Now, what is the data? You could pass it to it through a list. So you said N1 to N4, N1 to N4. Right? We have learned that from last time. So in here, what did we do? Added one column to the data frame using a list. Using a list. If I need to add another one in here, I could run this program, this line again, with a new title and the new data. Okay? In here, what we are doing in here, I'm adding a column using what? A series. In the previous slide, I'm adding using a list. In here, using a series. It was added. So you could add one column using a list or using
Series.
a series.
So if you pass a list, it'll be a column, it'll be added as a column.
Yes. It's in here. That's what I'm
Yeah.
saying.
Yeah.
This is a list,
Yeah.
and this is a series. All right. To add a row, we could add it as a dictionary
Yeah. Dictionary.
or as a list, or as a data frame or as a list. So to add a row, it has to be a data frame. So we create a data frame with one row. We concat there. Or as a dictionary. To add a column, could add it as a list or as a series. Easy? People in the back, are you with me? Are you with me?
Yeah.
Oh, good. All right. So in here, what we did in here, print, concat. What I'm doing in here, I'm concating how many data frames? 3. Column or column-wise or row-wise? Row-wise or column-wise? Column-wise. Why? Because I say axis equals 1. And then I said ignore index true. So ignore the index. So it did not copy the index. It did not put A, B, C, D, A, B, C, D, A, B, C, D. So ignore the index. That means it created a new index, numerical index. All right? All right.
Now it has become index, it's not variable anymore.
It's an index. What is the title of this index? 0. What is the title of this index?
Yeah,
1.
It's an index and a variable.
And the variable, yes. Yeah. The variable's here. We'll talk about that in a second. Okay? All right? Good? So, concatenation with different indices now. So, we learn how to concatenate a whole data frames together. We learned how to add rows to a data frame, 2 ways, right? Using dictionary and using data frame, 1 row data frame. And we learned how to add a column to a data frame using list and series. Simple. All right? In here, in the previous 2 methods of concatenation, the data sets combined are assumed to have the same number of columns and rows. They are identical sizes. This is not real life, is it? It's not real life, right? So here we consider 2 scenarios: concatenate rows with different columns and concatenate columns with different rows. All right. So look in here, for example, if you have in here the columns. Okay. So this is the data frame 1 has A, B, C, D. Data frame 2 E, F, G, H, and data frame 3 has A, C, F, G. You know. So these didn't intersect with any. But this one intersects with this, with H and F. And this intersects with this, with the A and the C. So the column. So the columns of the one is A, B, C, D. The columns of the second E, F, G, H. And the columns of the third one, A, C, F, H. Right? So in here, when we do concatenation, rows with different columns, here we have to agree it's different columns, right? Different columns, right? Okay, so we need to have this under this, and then this under this. We're gonna concatenate rows. But how can we do it if they have different columns?
Whenever it's the same we're gonna add it to the same column. If it's different, we create another column.
We'll see. That's what exactly happened. All right. So when we concatenated the 3 data frames and we printed it, so A, and then here because there is no values, it is not it printed it. Okay. So B, C. So like for example, A, it's available in how many data frames? In 2. Here and in here, right? But the second one, is it available? No. So look at the A, from the first data frame, no values from the second data frame, from the third data frame. B is available only in the first. C is available in the first and in the third. D available in the first only. E is available in the second. F in the second and the third. G in the second. H in the second and the third. Alright? So in here we are concatenating rows, but the columns are different. Yes?
So make sure you understand something you talked about before. So if we use ignore index, then that would be 0 to...
No, index will be 0 to 12.
Whatever it is.
Yes. Yes. So concatenation rows with different columns, So one way to avoid the inclusion of non-values is to keep only those columns that are shared in common by the list of objects to be concatenated. So the parameter name join, you could add join, accomplishes this. By default, it has outer value. That means include everything. Okay? But if we do inner, it will remove the one is not, it will keep only the columns that are shared. Let's take a look in here. So again, the same thing. DF D2 through 3. Join inner. That means keep only the columns that they are shared by the 3. How many columns are shared by the 3? 0. There is no column shared by 3. Let's go back in here. Okay, so the A, it is shared by the 3. It's not shared in here. The B is shared by the 3.
No.
It's not shared in the other 2. C is shared by the 3. It's not shared in here. D. Okay, so only include, if I do inner join, it will only include, that's why when I did the join, what did I get? Nothing. Nothing, all right? Concatenation rows with different columns. Okay, so if we use the data frames that have columns in common, only the columns that all of them share will be turned. So for example, if I do data frame 1 with a 3, how many are shared? A and C. So that's why I have them. The A and C, that's why I have them, right? So I have to know what I want, right? So when we need to concatenate columns with different rows, now different rows, not different columns, different rows. So in here, for example, I have A, B, C, D, E, F, G, H, A, C, L, okay? Okay, so now if I look at the index in here, okay, this is 0, 1, 2, 3, 4, 5, 6, 7, and so on and so forth. This is 0, 2, 5, 7, all right? So now I need to concatenate them by columns, right? So I need to put them next to each other. How it will work? Same thing, all right? Same thing. So the A will be together, okay, the B together, the C together, okay, and so on and so forth. Okay, and this is, I'm concatenating the rows. Why? Because they have the axis equals 1. Okay, so the A, B, C, D from the first one came in here. Do I have indices 4, 5, 6, 7? I don't. So then the E, F, G, H, okay, but I don't have the indices 0. Okay. Now in here, if you look in here, this is in here by the row. Let me go back. You see, this is gonna go to row 0, row 2, row 5, row 7. And that's why I have 0, 2, 5, and 7.
One concatenates the rows or the columns?
Here,
One is
1 the columns.
the column. Okay.
Yes, columns, add columns. Adding columns to each other. 0 adding rows to each other. Okay. 0 expand down. 1 expand right. Down, right.
Shape 0 and 1 is rows.
All right, so concatenation columns with different rows. So if I say join inner, same thing happens. Only 0 and 2 has all of them. That's why they are included. The rest are removed. Okay, if I go back in here, where is 0 and 2? Well, 0 and 2, okay, included. This is only data frame 1 and data frame 1 and 3. Okay, so far we are good. We learned how to concatenate data frames together, how to add columns, how to add rows, how to concatenate concat. Let's say concat. Concat reminds me with KitKat. Concat, with different. If the rows are different, with the columns different, the tricks there. Inner and outer. Okay. So, okay, merging multiple data sets. Panda has bd join command that uses bd merge under the hood. Okay, join. So join will merge data frame object based on the index, but the merge command is much more explicit and flexible. So 3 types of multiple data set merge. There's 3 types of merges. 1-to-1 merge, many-to-one merge, and of course, many-to-many merge. So let's say that we have 4 data sets. The first one, person, we could load it from here, the file. You have it, by the way. Site, we could load it from here. And survey, we could load it from this file. And visited from this file. So how many data frames I have created? 4. They are ready for me in the memory. All right, and the files are available for you in the shared drive in Canvas. You could use them. All right, let's take a look at them. So if I print person, so the person has how many columns? 3. The identity, the personnel, the family. Identity, the personal, first, second, maybe the last name. That's the person, right? The site, how many tables it has, how many columns it has, 3 also. Name, late, long. Okay, I don't know what doesn't mean, I forgot. So maybe it's like a music or something. Okay, and then you have the visited. You have identity, site, dated. Okay, 3. And this will has taken, the survey taken, there's a survey taken, person, the person, so this person, for example, has how many surveys? 2 surveys, 2. 2. Okay, so quant, rad, sal, I don't know what does it mean, and the reading, whatever, the reading of something. Anyways, it's a data, all right? It's a data. And by the way, like many times when you work with data sets for machine learning, deep learning, there's something called features. You could find like 100 features, 200 features. It's not necessarily all the time you understand the meaning of the feature. Okay? So you have to deal with it statistically as a value. It could be a number, but you really don't know what are the numbers. All right? You could calculate the mean, the average, etc., all of these things, and you deal with it, right? Anyways, we have 4 data sets in here that we have to deal with. All right. So how pandas parameter relate to SQL? So in Panda, if we have left, what's trying to do in here? We're trying to join data frames, 1 to many, or many to many, or many to 1, right? And this is very common thing to do where in databases, right? That's what you do in database, right? So so left, in balance we call it left outer, keep all the keys from the left. Right, keep all the keys from the right. Okay. Outer, keep all the keys from both right and left. And inner, keep only the keys existing both. All right? You understand what I'm talking about, right? I think you understand, right? So let's try. Okay, let's say that I have a table, for example, student number, first name, last name, okay, and have another table as a student number, okay, address, email, phone. All right. So I have a table. If I need to know the phone number of the person, his ID 1, 2, 3, 4. Can I get his phone number from this table? I can't, right? So what I have to do? I have to join it. So I could have this person has 1, 2, 3, 4, and 1, 2, 3, 4. So he has different address 1, for example, address 2, email 1, email 2, phone 1, phone 2, for example. All right? So what we call this in here? Primary key, right? In the database language. And this we call it? Foreign key in the database language, right? So, and many times when I have multiple data frames, multiple tables, what I have to do? I have to join them. Generally speaking, what kind of joins there? Okay, it could be left. All right, left, keep all the keys from the left. So where's the left? Let's say that the left. You're gonna keep everything and one from here. Or right, you're gonna keep everything from here and one from here. Or what they are intersect, what are intersecting here. Or everything. Right? So I could create another data frame, one from here, everything in here. Or one from here, everything in here. Or everything from here, everything from here. Or whatever intersects in here and here. Right? That's what's joined, right? In general. So when we call this method, the data frame that is called will be referred to as left. Okay? And within the merge function, the first parameter is the right parameter. So let's take a look. And of course, we're going to use left on or right on. Left on or right on. So, okay, there is, okay, when we look at the visited, and we're printing the location 0, 2, and 6. 0 and 2 and 6. And we save it where? In a visited subset. Okay, so refresh your memory, where is that visited? Where is visited? There. No. Person. Visited in here. So how many we have? How many? 3. So we're going to take a subset. I think it was 0, 2, and 6. Okay? That's what we did in here. 0, 2, and 6. All right? So how many rows we took? 3 rows. How many columns? How many columns? 3 columns. Because we did not specify anything. That means we'll take all the columns. You're going to take 3 rows and 3 columns. So, right?
Yeah, 3 columns from each. Or from, isn't it you take all the columns?
All the
both
columns.
tables?
All the columns. Because, okay, yeah. But we have 3 columns. That means 3 columns. In the visited, how many columns we have? How many columns we have? 1, 2, 3. So you're going to take 3 columns. All the columns. And take 3 rows. So the default value for row of how, okay, so in here for the site merge, so we're going to use merge, visited subset. The visited subset has 3 rows and 3 columns, right? Okay, left on name, left on name, right on site. Okay, left on name, so it will join what? The name and the site. Okay, left on name, right on site. Okay, so let's go back. Let's go back. So this is visited. Okay. Left on name and where's site? Site there. Name. Okay. Name DR1. Okay. And site. Notice that site is the same information and the name is the same information, DR1, DR3, right? So you're gonna join them, because if you need to join two tables, you have to have at least one column is common. How can you join them? Right? How can you join them? You have to have one column is common. What is the common column? In the site we call it name. In the visited what we call it? Site. Right? Alright? So that's what we did. So merge, site, merge. We call it name in the site. In the visited what we call it? Site. Alright? Print, and now it's printed 0. So we joined like 3 records in here, 3 rows. It has the name, the late, the long. This is coming from where? From the site. If you go to the site, name, lat, long, latitude and long. Name, lat, and long. And this coming from where? From the site. What are they? Identity, site, and date. Identity. Okay. Which one? Yeah. Here. Physical. Which is identity, site, and date. So now we join. There's 2 labels, 2 tables, 2 data frames. Each table frame has 3 columns. One of the column is common. So we join these 2 data frames using that common column. Simple. Okay. Now we created a data frame which has how many columns? How many columns? 6, right? But, right? But
So it joins.
the name and the sign are the same because that's how we join them. DR1, DR1, DR3 equals to DR3, and MSK4 equals to MSK4. So we joined them using this. These came from one table, and this came from the other table.
If they have the same name, it's gonna be one column, or it's still gonna be
Two columns.
Even if it's the same name of the column, like name.
If they have the same name, it will rename it for you. It will give it underscore something. Okay, it will rename it for you. Okay. Another example: site merge visited, left on name and right on site. So you are merging what? Site data frame with visited, and you join them together. Okay. Another example in here. Okay. Many, and this is many to many merges. Many to many merges. All right. So you have the person merge with survey, left on intent and right on person. Okay. When you print PS, okay, it will print it for you. In here, joined visited with survey. Okay. Anyways, and this is when you print it. Okay. All right. Many to many. Okay, so and here PS merge, the one we created two, right? We created PS and VS. We have now two data frames. We need to merge them together, it seems. Okay, so PS merged with the VS, okay, and left on many, right on many. So that means identity equals to person, taken equals to whatever, quant equals to quant, and reading equal to so and many. Okay. All right. So pandas will automatically, that's your question. Pandas will automatically add a suffix to a column name if there are collisions in the name. Okay. So in the outer, underscore and underscore x refers to the values from left data frame, and underscore y for the one from the right frame. So it will take care of that for you. All right. Let's take a break, 5 minutes, and we'll come to talk about missing data. So there are many representations of missing data. Okay, always you could have missing data. So in the data sets, they could be as null values. So the program languages use NA, and depending on what you get, some of them represent them with different values, like in health whatever, 8 or 99. In pandas, it will be displayed as NaN or NaN, right? That's how it is displayed. All right, so the NaN value in Panda comes from the NumPy. So this also in NumPy. Missing values may be used or displayed in a few different formats, the same meaning, NaN, capital N, small a, and NaN, this way, the same thing. All right? Just import the NumPy missing from NumPy import, whatever. All right. The most important thing that you need to know that NaN is not equal to 0 or empty string. It's not 0, it's not empty string. NaN is not 0. Yes?
So is it like null?
Huh?
N-U-L-L? Like null?
It's null, yeah. NaN is null, but we don't use it null in here. It's kind of not defined value. So it's not 0. In many languages, non equals 0. It equals to 0, right? All right. Here no. All right. So for example, missing values are tested for equality. Print NaN equals true, false. True is not NaN. It's not false. It's not 0. It's not empty string. They are not equal. So NaN is not empty string, not 0. Okay, not false. All right. Okay. Checking against other missing. So if print NaN equals NaN, false, NaN equals false, false, false. Okay. All right. So pandas has built-in methods to test for missing values. Again, what are we talking about? That you have a data frame, could be like millions of records. It's so normal, so typical that you have missing values. So you have to check for them. The NaN will, the pandas will provide you with methods for that. All right. So for example, print is null, NaN true. So you don't check it with the equality check. It will not give you anywhere, get you anywhere, right? You have to check it with the methods provided by the pandas. So is null NaN true? Is none NaN true? Is none NaN different format? Used in different way? True. So that's how you check the value equals NaN. All right, with the methods provided. Okay, no, not null. 42 true. 42 is not null. That means it's true. Not null missing. True. Missing is not null. Right? It's a string. Right? Okay, not true NaN. False, because NaN is not null. So there's two methods provided for you. That's the only two methods that you have to use to check for missing values. Okay, what are they? Is null and not null. Fair? Fair. So where does the missing data come from? Why we have a missing data? It could happen when you load data from the files. The files, they have missing data. Or when you merge data. We just saw in a few seconds ago when we merged data, okay, we created like a data frame with lots of nands, right? And user input values and reindexing, if you do reindexing. So these are the reasons why you're having data. So let's start talking about why you have missing data. So loading data, okay? So we use read CVS function. 3 parameters relate to reading and missing values. So if you have a CSV file and has missing values, what you do with it, how you read it, you could control that. All right. So you have NA values, keep default NA, and NA filter. Let's take a look what they do. So you could tell the file when you load it, for any NaN value, replace it with this value. Okay? Or do something with it. There's rules, okay? So that will help you when you we deal with that. So the first one is NA value parameter allows you to specify additional missing NaN values. Additional missing NaN values. So you can pass in either a Python string or a string-like object to be automatically coded as missing values when the file is read. So when there's a missing file, substitute this missing values, substitute this missing value with this string or with this value. All right, you could control that. All right. The default missing values such as NA or NaN are already available, which is why the parameter is not used. So if you don't supply this, by default, all the missing values will be substituted with what? NaN. But you could control that if you include that. Okay, some health data may code 99 as a meaning, right? For the health code 99 as a missing value, or specify the or specify the use of this value. You would, for example, say NA values 99. So whenever in that file you're loading there's empty data substituted with 99. All right. The other one is keep default NA. Okay, keep default NA parameter is a boolean that allows you to specify whether any additional values need to be considered or in missing. Okay, so the parameter is a true by default, meaning any additional missing value specified with NA value will be used. All right. Maybe the example will make it the clearest of examples. Okay. Okay, look in here, for example. We are loading a file called survey_visited.csv to data frame. We call the data frame visited file. So this is a data frame. Okay. All right. So when we read it, we did not specify any parameter, did we? We did not, right? So it loaded everything, and whenever you have any missing value, it will replace it with NaN as a default. Okay, if there is any missing value, we'll replace it with NaN. We have how many missing values in this table? 1. Replace with NaN. Can I control it? Yes, I can. So in here, what I did, I read it, okay, and I said keep default false. Okay, what is the default? NaN. So keep default false. So what did I do in here? Did not put the NaN. Empty. It's an empty value. In here, what I did, okay, NA value is empty string. And then I said keep default false. Okay, false. So what does it say? When I say, so when there is empty string, it will get replaced with empty string. Okay, so manual specified missing value, manually specified missing value. In here, I'm loading two data frames, one from survey visited, and the other one from survey visited and visited survey. Okay. Survey, no, this is survey, and this is survey visited. Survey, and survey visited. All right. When I load it normally in here, as you see in here, there is one missing because I did not specify any parameters for the visiting loaded normally. In here, the same thing. When I loaded it, I did not specify anything. It will replace any empty value with none. Any empty value with none. Any empty value with none. Why? Because I did not change the defaults. I did not add any parameters there. Okay. So in here, merge data. Okay, merge data. So so the first reason why we have empty values is because we load the data. The data will load. The files have empty spots, so we could control it. The other reason, like in here, the other reason is merged data in here. Merge data. When you merge the data in here, okay, you merge data in here, right? As you see in here, when you merge data, you're gonna have, you know, missing values. So you replace it by default with none. In here, by user input values. User input values. So for example, so in here you have a series goes equals 4 and a mobile none. Okay. So the series that you are created has no value. Has no value. Okay. Print the num-leg. So you have a mobile none and the goal 4.0. If I need to add it to the data frame, okay, to the data frame, all right. So the missing, it will be having no value because I did not specify any value. So again, what is the reason any data frame could have a missing value? Number one, when you load the file, it has missing values. Number two, when you merge data frames. Number three, by design, that you're doing. When you create a data frame, but some of the parameters you didn't specify a value for it, then it have a missing value, right? So in here, also another example for user input values. Okay, so in here what you have, you're creating what? A data frame. Using what? Dictionary. So name, occupation, born, dead. Okay. Is there an issue? No. Then you added one more column, you call it missing. And you give it the value of none. So it's by your own doing this, that you have created this missing values. And the fourth reason is by reindexing. By reindexing. So look in here. So for example, you read a CSV file and you save it in a data frame in here. All right. When you try, what you did in here, you subtracted life expectancy from the year life expectancy from the mean. You calculate the mean for the life expectancy. You subtracted from the life expectancy for each year. Okay, for each year. So this number is a result of subtraction of the life expectancy or the mean of the life expectancy from the life expectancy. Okay, in here. All right. If I do reindexing for this, reindexing, okay, so what I did in here, okay, reindexing range from 2010, I have created many missing values. So 4 reasons usually, again, to have a missing values. By loading a file that has a missing values. Number 2, by merging data frames. Number 3, by the user input. Number 3, by reindexing. All of this a reason to have. In your opinion, what is the major reason among the 4 to have this problem? Maybe merge or the original data, both. Data. It's like have missing data. Okay. So how you work with the missing data? Now we know how we're gonna have the missing data. Why we're having the missing data? So how can we work with it? How can we work with missing data? So in here, from the country time series, we loaded to Ebola. We'll try to read the Ebola disease. If Ebola.count, okay, look what tell you. I mean, this is other columns. So the date you have 122 entry, day 122 entry. All right. Cases Guyana 93. That means there is some missing entries. Right. Only 93 are provided. In Liberia 83. For example, in here deaths in Mali, only 12 entries. 12 entries. So how many columns we have? All of these columns. How many entries in each column? This is how many entries in each column. So it's clear in this data frame that there is a lot of missing values. Okay, missing values. So how many? If the number of rows is 122, how many missing dates we have? If the number of rows 122, how many missing dates we have? None, 0. Because 122 minus 122 is 0. All right. If the number of rows 122 and we have only 12 entries, how many missing values we have?
110.
110. Right?
Yeah.
That's a missing value. Calculate the missing values. So in here, okay, Ebola. I mean, when you do shape, what does it give you? A tuple. How many elements in this tuple? 2. The first one tells you what?
Row,
The number of rows. The second one,
column,
the number of columns. So if I read the shape of 0, give me what? The number of rows. When I do the number of rows, and okay, so that's the number of rows. So number of missing, number of rows, which is 122 minus Ebola count, gave me how many missing. So how many missing in the date? 0. In the day, 0. Cases, whatever, 29. In Mali, deaths, 110. Right? Right? We do that. So, okay. So import numpy as working with missing data. So import numpy as np print the count non-zero. Count non-zero Ebola is none. Remember, if we need to know in pandas if null or not null, we have to use 2 methods. We have to use only 2 methods. What are they? Is null and not null. Is not and not null. So Ebola is not null. Okay, Ebola is not null. Okay, and then what I said, count non-zero. So missing values for data frame. How many are the total missing values? 1,214. All right. If I need to know the missing values for cases Guyana, so is null, not 0, 29. So this is just like, how to write the code to find how many missing values. I mean, that's the first thing. You're working in a data set. You load the data set. What is the first thing you have to do? Many things you have to do, actually. I don't know which one is first, which one is second, which one third. But for sure, one of the things that you have to do is to deal with missing values. And to deal with the missing values, you have to know where are they missing. How significantly they are missing. Is it 1 or 2 values or much more than that? So there's tools provided for you to do that. Right? All right. So that's what we do, right? Okay. So you know how many the missing values. All right. All right, so working with the missing data, what you need to do, okay, you need to do cleaning missing data, or cleaning can be done by the following methods. Now you have to clean the data by record, replace, record or replace. You have missing data, you need to replace them with a certain value or record them. And that depends on your need in the program. Or by fill forward, we'll explain it, fill backward, interpolate, or drop missing values. Drop the missing values. Anything else you could do with the missing values? Can you think of anything else? You could replace the value. You could fill forward, fill backward. So fill forward, just replace it with the value before it, similar to the value before it. Fill backward, replace it with the value after it. Interpolate and drop value. So let's take a look. So, and to do that, there is a method to do that. Fill now method to record the missing value. So in here, what we did, for example, look in here. Okay. So Ebola, okay. Fill now 0. That's the value. Okay. For the first 10 rows and the 5 columns. So what we are doing in here, for any null value, we replace it with what? With 0, with a value. Fill null, fill none, null with 0. And you specify which rows and which columns. If you don't specify, that means the whole data frame. Fair? If I need to replace the missing values with X, what should I put instead of the 0 in here? X, for example, right? Replace it with it. So that's what we call it. You know, we call it record or replace. Record or replace with a value. So full null, like many other pandas functions, okay. Many other pandas functions has a parameter for any place. Fill forward. What is fill forward? So fill it similar to, so this was missing. Fill it to the one before it. This was missing. Fill it to the one before it. And here what I do, is there anything before it? No, so I cannot replace it, I cannot do anything about it. So I need to look at the one before it. Is there anything before it? No, I keep it as it is. How about this? Keep it as it is. How about this? I look to the one before that. Replace it with that. So in here what we do, method fill now, method forward fill. And you specify where. Fair? Okay. Then in here, fill backward. So in here, I cannot do anything with it. Why? Because there is no values. There is no values, right? There is no values. Okay, and so on and so forth. Okay, there is interpolate. Interpolate. And this is very interesting. Interpolate, third way, interpolation uses existing values to fill the missing values. So basically what you do, you try to calculate the average between the next one and the previous one. So you take this and this, add them, divided by 2, you put the value in here. Okay, so it's like you calculate the missing values linearly. In here, for example, okay, you take this and you average. In here, you take this and you average. It was missing. The one had errors, they were missing, and so on and so forth. Right, in here, can I do it? there's no value before it, I cannot do it. So how can I average, right? All right. And there is also drop missing values. So we can use a drop in a method to drop missing data and specify parameter to this method that control how you drop. Now, what you're gonna drop? You're gonna drop the whole row, or you're gonna drop the whole column? So you have to specify, right? So the how parameter lets you specify whether a row or a column is dropped when any or all of the data is missing. Just control it. I mean, there is a row, you have a row in the data sample, it has a missing value. Maybe you're called to drop the whole row. Or there's one of the features, okay, that has a lot of missing values. It's no use for your data. Just drop it. Drop it all, right? Okay. Okay. The threshold parameter lets you to specify how many non-null values you have before dropping the null. So if you have, for example, 50 or more, don't drop. 50 or less, drop the whole column, the whole row. Right? Okay. So in here, for example, shape of Ebola, there's 122 rows, and how many columns? 18 columns. All right. When I say Ebola, drop node shape, it kept one row and 18 columns, and so on and so forth. So you know, it depends on what you're gonna do. You could do different things. Okay. All right. So you got what you are calculation with missing data. Suppose we want to look at the case counts for multiple regions. We can add multiple regions together to get new columns holding the case count. All right. So you have in here Ebola cases multiple. Okay. You are adding the cases Guana with Liberia with Sierra Leone. Okay. And you're creating this. Okay. Basically you're creating that. So you can see that a value for cases multiple was calculated only when there was no missing values. When there's no missing values. Okay? Missing. Because if you're trying to add these values and one of them is missing, it will not calculate, it will tell you it's a missing value. Okay? So examples to build in methods that can ignore missing values. I mean, sometimes you have missing values, but you need to ignore. I mean, there is statistical like mean, you know, the mode. So you need to ignore the missing values. So all you have to use skip. No. So in here, for example, Ebola, whatever, sum. You're gonna do the sum, and skip missing values true. So skip. You just don't add. If you don't do that, it will give you all not enough. It will give you none. Okay. In here, for example, false. It will give you none. But if you say skip not applicable, add them for you. Alright? So this is very important when you work with the average, with all the statistical, with the standard deviation, all the statistical values. If you have missing values, it will not work. You have to specify, please ignore missing values. Please ignore missing values. Otherwise, it will not calculate anything for you. Okay? It's different than Excel, different than many other things, so just be careful with that. We come for the last part of this class, which is the TD data. Okay, so data can, okay, so columns contain values, not variables. We have to, columns has to contain variables, not values. All right. Usually the column could have values instead of variables. We have to remove that. It is usually a convenient format for data collection and presentation. Usually when you collect the data, it's very easy that we put a lot of values or make many columns that contain values, not variables. Values, not variables. It's easy to collect the data. When you try now to use the data set for a statistical operation, it will not work. It will work, but make it more complex. So how we can do that? There's two methods. Keep one column fixed, keep multiple columns fixed. Let's take a look here. Okay, so in here we are reading of statistics about religions. I think I don't know where. So for example, agnostic. How many people make? There's a survey. How many people make less than 10K? 27 people. Between 10K to 20K, 34 people, and so on and so forth. Right? Okay. So you have So in here, religion is what? A variable. Religion is a variable. But this is a value, not a variable. Okay, a value, not a variable, right? So so this table, this data frame, awkward. Okay, we have okay. Why is it why religion is a variable? Because a unique value. It's not repeated, right? Why this is a value? Because we could flip it like this. We could have agnostic, and we have and all these values goes for the agnostic, because all of this belonging to the it's a value, kind of value, right? So the values that relate to income are spread across multiple columns. That's wrong. We should not have that, right? For data analytics, the table needs to be reshaped. So we have religion. We need to have only 3 columns. We need to have religion, keep the religion. We need to have the income and the count. Religion, agnostic. Okay, the count 27. The count, there is the income. Okay, income. And the count, how many is the count? All right? So how can we shape this differently? Is there anything wrong with this table? Maybe not. But for statistics, for what you want to do, it's not the right format. Okay? We need to have only 3 columns. Okay? Religion, income, okay, and the count. Religion, income, and count. Right? That means in this column, religion, agnostic, how many times will appear?
4 times.
1, 2, 3, 4. Right? 4, 5. Right? 5 times. That's a continuation. 5 times. Right? So keep one column fixed. Is Panda has a function called melt. Okay, melt, that will reshape the data frame into a TD format. Melt takes a few parameters. ID vars is a container, whether it's a list, a tuple in the array from NumPy, that represent the variables that will remain as is. So in our example, which one gonna remain as is? Religion. Okay. Value vars identifies the columns you want to melt down or unpivot. By default, it will melt all the columns not specified in the ID var. So which one that we need unpivot to melt? This and this and this and this and this. 5. We need to melt them. Melt. All right. Then you have var name. So when you melt these, we're gonna have what? We're gonna have 2 columns. We're gonna replace them with 2 columns. One is the income and one is the count. Right? We're gonna melt these columns, 5, 6, 7, 10, and we're gonna create two columns. Right? One is
Income.
the income, which is in here, and the other one is the count for each income. And that's where we specify. So the var name is a string for the new column name. When the value of var is melted down, by default it will be variable. That will be the variable. And the value name, it will be the value. Let's take example of this thing. So let's just repeat what I just said. Anybody is lost in here? Okay, anybody's lost? Everybody is lost? Are you lost, guys? No? Are you lost? You're here still? You're lost? You're not? Not at all. You're good, right? Alright. So basically, you know, let's just take a look at this problem. This in here, we have a table that has the religion and range of salaries and the count. Alright? So this is gonna stay. This is gonna melt them and replace all the 5 columns with 2 columns. The income and the count. The variable and the value. Call the variable and the value. So what we do, very simple in here, melt the data frame, and what is the ID vars religion? That means the only one it's not going to be melted is what? The religion. So when you print it in here, what you have? Religion, as it is. Variable, no name. Remember, it will give you variable and value. Variable, which is the range of salaries, and the value, how many people. So we moved from this ugly shape to this shape that we could do have more operations, more statistics. All right? So this is the head and this is the tail. This is the head and tail. So variable and value, which we could rename them later, right? So in here we can change the defaults so that the melt and pivoted columns are named. So what I did in here, ID vars religion. That means that will stay without melting. Var name income and value name is count. Now I named them. So what I got the religion, the income, and the count. And that's the tail of the data frame we have created. So we melted it, right? All right. Keep multiple columns fixed. So not every data set will have one column to hold still while you unpivot the rest of the columns. So let's take example in here. So in here, you loaded this data frame, okay? And when you printed it, okay, so you have the year, the artist, the track, the time, the date entered, okay, the date entered, and then you have week 1, week 2, week 3, up to whatever, 31, how many weeks? You know, many weeks, right? Okay, so do you think this could be melted too? So this is like values, not variables. Right? You could melt it, right? Okay, so it could be melted, right? All right, so what we do, we're gonna melt it, okay? Then the ID vars, whatever an ID vars will stay without melting. So we don't want to melt year, we don't want to melt artist, we don't want to melt track, we don't want to melt time, we don't want to melt data entered. We're gonna melt what? Everything else. What is everything else? The weeks, right? We're gonna melt the weeks, right? And we're gonna give that variable name as a week, and the value is the rating. So the rating will be the value, and the variable will be the week. Okay, week. So now if I print it after we melted it, look how it look, how neat. You have the year, artist, track, time, date entered, week, which is the variable, and rating, which is the value. So basically, instead of the table was wide like this, it's like wide like that, but you could do much more statistical work with it. All right? This is a very crucial thing when you try to work with the data frame, that to take a look at your data frame and start see what you're gonna do, how to shape it. When you work with machine learning, deep learning, you have the data sets. They come in different, in many shapes and many formats. You have a lot of missing values. All right. So the idea of TD data that you have to have all the columns as variables, not values. So you could reduce the number of columns big time. In the language of machine learning and deep learning, we could reduce what? The number of features, attributes big time. If you anybody worked with machine learning, deep learning before? A little bit. So the first thing you do when you try to work in machine learning, deep learning model, what you do?
Train.
Huh?
Train. Get all the data set and train the system. Right?
Yeah, that's before training. What you do?
Before training,
Yeah,
Import all the data.
accumulate all the data sets.
you have to do feature reduction if you can. Feature reduction. Like PCA, for example, if you heard about it, principal component analysis, and different things to, because if you have so many features, the system will be complex, will be slow, sluggish, and will not provide you with the correct data. So you do feature reduction. Many people ignore this from the very beginning, that you could do feature reduction by melting many of the columns, the attributes. Then after that, you look for many other techniques for feature reduction. That's too early. I mean, that's to take 10 different class. All right. So you see in here, we did like a feature. All right. So columns with multiple variables. You could have columns with multiple variables. So sometimes columns in a data set may represent multiple variables. Multiple values. This format is commonly seen when working with health data, that column name, like case iguana and death iguana. So this is what? There's two variables here. What is the first variable? Cases. What is the second one? Country. What is the first variable here? Deaths. With the second variable. So one column has how many variables? Two. So you have to what? Separate them. All right. So the individual status, cases, and this one variable, and then the country is another variable. So for that, what you have to do? So this, when you look at for example, the columns, so you have date, case iguana. This is two variables, and so on and so forth, right? That's how you print some of the columns and some of the rows. You have date, case iguana, whatever, Liberia, Ghana, whatever. Okay. So what you need to do is to, in here, the Ebola log, melt the Ebola, ID var, so keep the date, and the day, all right? And melt everything else, so the variable in here, case iguana, okay, and the value, So how to split? So this one, how to split in here? How to split this? So in here, how to split it in two? All right. So conceptually, the column of interest can be split based on the underscore. So you have in here the name underscore. I need to split it based on the underscore. All right. So there is a split method that you could use. In here, what you do? So variable split. If all along the variable string split with the underscore. So when I do the split and then display only the first 5, I will have a series of lists. Cases 1, cases whatever, okay, all the way down. All right. Same applies for the other values. So this is in here. Cases, here cases, and all of that. So in here, if I need to add, okay, and here, as you see in here, look in here what I did. This is the variable, cases, guana, and the value. What I did, I divided this into columns. This variable in 2 columns, cases and the cases and the name of the country. All right. By using the underscore between them. Again, what's the problem in hand? The variable in here, column, is 2 variables in 1 column. It's 2 variables in 1 column. What is the first variable? Cases, which it could be what? 2 values, either cases or this. And the second one is the country name. So I have to divide this into columns. All right, divide that into columns. All right. Could you skip this? The combine could take a look at it. All right. The other problem is when we have variables in both rows and columns. So before, okay, so far we solved 2 problems. What is the first problem? That we have columns which are not variables. They are values. So what we did with them? We melt them. Melting them, so all of this value columns, we converted them to only to 2 columns, variable and value. What we call this process? Melt. Right? Melt. What is the second problem we try to solve?
I have 2 variables in 1 column.
We have 2 variables in 1 column. 2 variables in 1 column. Like we have, this separated by underscore. So we separated them, right? Okay. Now we come to the third problem. And that's why I always tell you guys you should sit in the first row. But always, people in the first row, they understand most of the stuff. And they answer the first. I don't remember all my life I sat in the back. Except when I came to UB. Okay, always I sit in the first row. All right. What is the third problem in our hand? Exactly. So a variable both in row as well and the column. So this is a good example in here. So look in here. So in here, for example, what happens if a column of data actually holds two variables instead of one variable. In this case, we will have to pivot or cast. Pivot or cast is the opposite of what? Of melt. So in here, what you have in here? Values. So how we solve this problem? By melting. We already learned how to do the melting, right? Melting or ambivert, right? How about in here? You have the element in here, for example, here the temperature, right? So temperature max, temperature minimum, temperature max and minimum, right? So in here we have two variables. We have two variables, okay, in the rows. What are the variables? T max and T minimum. So we could move these to where? To the column. In here what we did? We reduced the column. And here what we do? We include. Why? Because these are variables. Okay? So in all of this you have only two values. Temperature max, temperature low. So we have to cast. We have to cast. So two opposite operations, melt or cast. So what is the first thing you're gonna do is to melt in here. So let's melt first. So melt whether what bars you're gonna keep? The ID keep it, the year keep it, the month keep it, the element keep it, everything else what are you gonna do with it? Melt. So when you melt it, what do you have now? Okay, what do you have? And we give like a day and temperature, we give names. So ID, year, month, element, and we replace all of these with two columns. The day and the temperature. But each day has two values, right? Max and minimum. So we could, next step we have to cast. It. So one of the main differences between pivot table and melt is the melt is a function and the pivot is a method. So to do the casting, what to do? The melt pivot. So what we do in here, okay, melt pivot table. Okay, the index is ID, the year, the month, the day, and the column element. Okay, the column and element. Okay, and the value are the temperature. So what will happen now? ID and year and the month and the day. Now what we did with these in here, we pivoted it. We pivot, so we have temperature max and temperature minimum. So day 1, day 2 will have both. So to fix your data, it's not only you really have to understand your tables, your data frame. With some of the columns you have to pivot them, and some of the columns you have to unpivot. Melt or cast. And this has to be perfect work before you go to the next stage. Perfect work before you go to the next stage. All right? Last thing I want to talk about normalization. Multiple observational units in a table. So one of the simplest ways of knowing whether multiple observational units are presented in a table is by looking at each of the rows and taking note of any cells or values that are being repeated from row to row. Just take a look, see if there is things repeated row to row. So for example, in here, what is repeated? Okay, look in here, year, the same. Okay, then in here, artist repeated. Okay, then the time date, and then after the, so this is clearly should be divided in two data frames. You will have the year, the artist, the track, the time in one table, and the date maybe. And then so this will be for information about the track, and there's another table should be about the rating for each week. So you could divide it in two table frames or data frames, and you could join them. When you need to access, you could join them. Otherwise, you will see a lot of repeated data. A lot of repeated data. That's what is normalization. Okay, how to change the look of the data. Try to reduce the amount. You agree on this? Okay, so look in here, for example, year 2000 and artist, anyways, it will be repeated. So it's clear. So in here, okay, so look in here, for example, when you print it in a different way, I mean, it will, okay, we're trying to look at the track loser from that data frame. So, year, artist, track, time, enter date, or date entered, okay? All of these should be repeated data. All of this repeated data. And then here we have 5 weeks and the rating for each week. So you'll have a huge file with a lot of repeated data. You agree? So what we should do in this case is to replace the year, artist, track, time, and put all of these in one data frame. Okay, creating a new data frame with each unique ID. So you create a data frame, and for each one, you give unique ID for each movie, for example. Unique ID for each movie, all right? And we can then use this unique ID in a second data frame that includes the song, the date, the week number, and the ranking. So one kind of table for the ranking, and one table for the information about the song. But we have to create a unique ID that we could join them later. When we have two data frames, we need to join them. We have to use them with a common column. If I need to separate a data frame, okay, into two data frames, I have to make sure there is one common column. Clear? Okay. So what we are doing in here, look in here, okay. So Billboard songs, long. So in here I'm creating another data frame which includes only the year, the artist, the track, time. I'm saving it where? In the Billboard song. And the shape has 25,000 rows with how many columns? 4. 1, 2, 3, 4. So that's the first step. I took them from the data frame. I created a new data frame. Has how many columns? Right? What's the second step? These 24,000, how many repeats? A lot of repeats. So what's the first step? Drop duplicates. Very simple. I take it and drop duplicates. So now it has how many? I have how many? 317. How many movies I have in the whole database? 317. But because of the duplicate data, 25,000. Does that make any sense to keep it that way? right? So step 1, create a new data frame. Step 2, drop the duplicate. What's step number 3? Add the ID. The common ID. So very simple. I added another ID, very simple. So this data frame ID, and I gave it range, the length of the pillar sums. What is the length of the pillar sums? 317. So I create ID 0, 1, 2, 3 until the end. So number 1, I created a new data frame with 4 columns. Number 2, what did I do? Drop all the duplicates. Number 3, create a new ID. So this is a 1 data frame. This is a 1 data frame. Okay. Now, whenever multiple observation units. Okay, when I need, for example, in here, merge. I could merge the billboard songs, the old one with a new one on the data I'm looking for. Okay. So use the newly created ID column to merge. So that's what I did. So to merge on the data. All right. All right. So the rest of in here, okay, it talks about. You could take a look at that. I'll leave it for you to take it. It's very simple. The other thing is load multiple files using loops. I mean, usually in your work, I mean, if you need to load and merge multiple files, it would be very hard to do it manually. So you could have a loop for it. So you create an empty list. Okay. Use loop to iterate through the CSV files. Let's say you have 100 CSV files. You want to merge them. So what you do, first of all, put them in a list. Then loop through them and load the CSV files into pandas data frame and then append them together. Right? When you have so many data frames, that's the procedure. So I give you a code how to do it in here. You could take a look at it. Okay? And that's it. Any questions? Any questions? All right. So I think, thank you so much.